What is this thread? Sprocket, fetch me my machinery's handbook. You did what? In the litter box? Do you know what those things cost? The shelter gave me you for free, you know. Ungrateful little shit. Hello, Internet. My name is Quinn, and this is Blondihacks. I'm back on the vertical fire tube boiler project. There's a playlist for this down below if you're new to this series. It's a model boiler about 4 inches in diameter, 4 running model steam engines. Today I'm going to build the Smokebox assembly. It includes the chimney and the steam plumbing at the top of the boiler. Lots of cool stuff. This is going to be a longer video. I hope you like it. Let's go. The Smokebox assembly sits on top of the pressure vessel, and it serves to funnel the combustion gases out the top of the chimney, but it's also a nice warm spot on top of the boiler, so frequently a feed water heater will be plumbed through there to preheat the water going into the boiler. And if you want to someday add a superheater, then the Smokebox is where you plumb that into the steam input and output. Here's my boiler so far. This is just a naked pressure vessel, so let's make it a little less naked. I'm measuring the top here to compare against my drawings, make sure that reality matches what I think the dimensions of the Smokebox need to be. And wait a minute, why does every project on this boiler start with turning a giant chunk of aluminum? Well, see, I had this very clever plan where I was going to make the end caps for the pressure testing of the core that you saw earlier a little oversized, so that when it comes time to roll form the Smokebox cover, I can just turn one of those discs down a little bit. Very clever, right? Well, until I forgot and made those discs too small, and so now I have to make another one that's a little larger. I sure do like that power cross feed though. I'm making a roll forming mandrel here, same as you saw me do for the tube sheets earlier in this series, playlist below. I need a hole through it just like the other mandrels. However, I chucked up this old piece of stock and it has a hole in it already that is running off center. So I can't run a drill through that to enlarge the hole because the drill is just going to follow the existing hole and I'm going to have run out in the hole. There's a few ways around that, but here's a quick and dirty way. I've got an end mill holder in my tailstock, and I put a 2-flute end mill in there, and I plunge that through, because the end mill is cutting at the outside edges of the flutes on either side of the hole, so it's not going to be influenced by the runout in the hole. As you can see, that hole is now running true. Now the price I paid for that is that an end mill, when plunged that way to make a hole, is going to cut a little over size. So this gauge pin is a really nice fit in the base mandrel, but in this cap that I'm making, it's a little bit loose. But that's okay, this is a low precision operation that we're going to be doing anyway. To get a nice edge radius on it for the sheet metal bend, I'm going to use this trick you've seen me use before, which I think I learned from Adam Booth, and that's to use a corner cutting end mill. I don't have a radius cutter for my lathe this size, and rather than take the time to grind one up, I'll just use this end mill. This is going to get very screechy in a second, so I'm going to switch it to ocean sounds for your benefit. You're welcome. This trick does work well. The tool pressure's high though, so you gotta have low RPM and feed gently. The results are nice though if you can manage to fend off chatter. I'm gonna do a quick size check on this mandrel here before I finish. As you can see, it's supposed to be a little larger than the boiler shell so that the Smokebox cover will go over the mahogany cladding that's gonna be on there. I need 2 other holes in this fixture plate, so I'm centering up the mill table on a mill slot so I can drill through there, and then I'll just center the piece on the mill spindle by putting the gauge pin in there and then clamping it down in situ. And then I just have to zero the DRO right there, and I can easily locate my other holes. Sure do love this power Z feed on my mill. As with any roll forming operation, you need to find a way to clamp the stock to the mandrel, so you need holes through the piece that you're roll forming. In the case of the tube sheets that I did earlier, I used 2 of the tube locations for these holes. In case of the Smokebox, I've only got 2, so I'm going to use them both. There's 1 on each side for the steam pipe. I'm drilling those 2 a little undersized right now so that they can be enlarged later after the roll forming, because of course roll forming distorts the holes that are in the sheet because it draws material away from them. So you end up with holes that are no longer round and or oversized when you're done. But here you can see what I'm going for. This little kind of adapter plate is going to bolt onto the mandrel that I used to make the tube sheets so that I can make the larger Smokebox cover. Here's the brass sheet I'm going to use, so I just found a decent center point on that, and I'm just laying out the OD of the smoke box. Oh, come on, try faster. I'm sure there's sheet metal maths you can do to figure out exactly what the diameter needs to be for this, but I just make it substantially oversized, like a good 1/2 inch all the way around, and then face it down to size afterwards. The dimensions of the sheet metal after the roll forming are going to change a lot, and it's a soft body problem, and I don't mess with those. To cut this stock, I'm using a new to me tool, the fret saw. This is not something I've used a lot before, but I gotta say, they are delightful. Kozo Hiraoka and other model engineers swear by these things, so I wanted to try it out. For light duty cutting like this, where it's not worth dragging out the bandsaw, it's actually really nice. So this is a number 3 blade that I'm using. It's a saw that cuts on the draw on the pull, and it does a very, very nice job. You get really good control. It's easy to follow a layout line with one of these. It's not fast though, so bring your patience. To drill the fixturing holes, I'm going to use a step drill. There's just no substitute for step drills in sheet metal. They are awesome. Unlike a drill, they don't cause lifting forces on the sheet metal, which is what makes drilling sheet metal so difficult. Step drills cut on the sides of each radius, so they make very nice clean holes with no lifting forces. The only downside to these things is you got to make sure you have plenty of depth underneath them, because to get to the radius you need, you might have to go quite far below the material. So when using your T-slot like this, definitely check beforehand that you're going to have the clearance to get to the size that you need. But it's also nice that you can drill all your sizes at once. So I needed a larger hole in the center and smaller ones on the sides. Accuracy-wise, that's actually pretty good. I mean, that's a 1 or 2 thou clearance, which is about what a drill does on a good day. So I got my roll-forming mandrel in the lathe, and I put the new adapter cap on top, and then the sheet metal slides on there. And then I've got the cover plate that I used for the tube sheets. And then same as before, I start by turning down the OD. There's a little bit of run out in that mandrel, but it's fine. Again, this is all low precision stuff that we're doing. Deburr that so that I don't bleed all over my nice shiny new part. And now the best part, we get to play with fire because it's annealing time. Just like with copper, the goal is to get it to a dull red, and it helps to do that in low light, hence the darkness that you see here. And this softens the metal for easy forming. You can quench it right away to cool it off. Remember that non-ferrous metals don't harden when you quench them. They work harden, but heat only softens them, and quenching has no effect. Over to the roll forming mandrel then. This is the same process I showed for the tube sheets, so watch that video if you want more detail in what I'm doing here, but essentially I'm just annealing it periodically and then putting it back on the mandrel and rolling it over the mandrel using an old rollerblade bearing. In no time at all, I've got this nice sheet metal drum lid cap disc thing. Look, words are hard. Anyway, now I can trim down that flange to the proper depth. This is thin enough, this sheet metal, that I can just do it in a single pass, which is kind of cool. And once I'm at a depth that I like, then I can remove that cover plate and get my boring bar in there and open up the center hole for the chimney. And again, this is thin enough that I can just do a single pass outwards on the boring bar here, and this works out quite well. This material is so thin it's kind of hard to measure the diameter that I'm at, and there's a big burr in there, but I'm just guesstimating, and I'll make the chimney to fit. So I ended up about 5 thou oversized. That's fine, we can work with that. Now I set it up in the mill again using the same technique as I used before to open up these holes to the final clearance size that I need. Again, I'm doing this after the roll forming because the holes will stretch and distort during the roll forming. Okay, on to the Smokebox Plumbing now. I need 2 long, skinny steam pipes. These are kind of interesting parts. They funnel the steam up out the top of the boiler from inside the pressure vessel, but they also act as hold downs for the hardware, as you'll see here in a minute. Now, this piece of stock has an old center in it, but you can see the center is running out, so I want to recut it. Now, the proper way to recut a center is using the compound to recut it with a single point tool, like a tiny taper. However, here's a shortcut way that I learned from Adam Booth for doing it. Just put a larger center drill in there and apply some lateral pressure to the tailstock with the tool post, and you can get it to cut only on one side, kind of like a single point tool. And well, it does a nice job of recutting that center, as you can see there. It's now running perfectly true. Now with the tailstock in there, I can take some heavier cuts. So I'm doing a couple of heavy passes here to get down to the overall diameter. The stock is a little oversized for these pipes, but I had it on hand, so I wanted to use it. Plus, I get to take big girl cuts in brass, which is always fun. After those rough cuts, a nice little fine cut to make it look pretty. These pipes have a whole bunch of different diameters on them, so I'm going to get some Sharpie on there and mark them out. I finally found a way of setting odd leg dividers that doesn't make me crazy. I use this new indicator stand that you saw me build recently to hold my calipers, and I can set the dividers thusly. It's very pleasant. And now I can mark out all the different diameters that I need and turn things down to the lines. Just turning to the lines is sufficient precision here. These are very low precision parts, just plumbing fixtures. The far end here has 2 different threads on it. It's kind of interesting. One is smaller than the other. So I do all the diameter turning first so that I can thread the larger diameter over the smaller one, like so. So I got my 3/8 24 die here, and this thread here is just the area that acts as the clamping bolt to hold the smokebox lid in place. That's looking good. And then I come back in with my 1/4 40 die and I turn the smaller outboard thread, and this is where the actual plumbing fixture attaches. A quick deburr, and now I'm ready to drill it all the way down the center, which is, what makes it into a plumbing fixture. Without this step, it's just a really elaborate bolt, I guess. This is a very high aspect ratio hole, meaning that the depth is much, much greater than the diameter of the drill. You're going to quickly overwhelm the efficiency of the flutes for clearing chips, and so you have to clear the drill frequently. And the quickest way to do that is to simply unlock the tailstock, slide it back, clear the drill, push it back in, lock the tailstock, and resume cranking. There's a final diameter behind the wider shoulder area here, and I'm going to do that with a grooving tool. I'm going to be flipping this around for a second operation anyway, so there's no need to do it this way. I just have this obsession with doing things in one setup if I can. But this shows you how you could do this if you needed to do it in one setup to maintain concentricity, for example. I simply plunge in until the diameter is correct, and then I plunge in adjacent to it to the same value on the hand wheel, and then I pan across to make sure the surface is all at the same depth. And pull back out, and we end up with a nice finish and the correct diameter, and now I can part off just outside of that. And Yahtzee. All that's missing now is the thread on the other side, so I thought, well, I'll just flip it around, wrap it in some protective shim, and cut the thread this way in the 3-jaw. Unfortunately, the part is slipping, which often happens cutting threads in brass with a die because it's so sticky. And I don't want to clamp the jaws too tightly on this part because it is a hollow tube which could get crushed by the chuck. So it's over to the Collet Chuck. One of the lesser sung superpowers of the Collet Chuck is that it grips the entire surface of the part, so it has a much better grip with less clamping force. And so it allows me to easily clamp on this little part and cut the threads. Before I do that, though, I use the parting blade to make an undercut at the base of that thread so that it'll sit down nicely on the boiler bushing. And to do that, I go about 5 thou smaller than the minor diameter of the thread. Now for the mystery part of the show. This is the second steam pipe, and it has a thread on it for the safety valve. This safety valve is from PM Research, and it says it has a 5/16 27 thread on it, so that's what I put on it. And the safety valve does not even start. Not even a single thread will engage. So that's weird. So I did some investigating. I checked the pitch of my thread, 27 threads per inch, perfect. I checked the major diameter, 5/16, so there it is, perfect, couple thou of clearance, and still doesn't fit. So I called PM Research, and they sent me this adapter fitting that does thread in, just so I'd have a male thread to compare, and it works, so okay. So I took my 5/16 27 die and threaded it on there, and it fits, but it's loose, so that's weird. So then I thought maybe it's 1/16 NPT. So I put that die on there, and that fits very well. So this is actually 1/16 NPT apparently, which is very close to 5/16 27, but it's actually National Pipe Taper. It's a very small pipe thread. So I recut the thread on my part with the 1/16 NPT die, and the safety valve does not thread on. Now I'm really confused, because that really should have worked. I took my 1/16 NPT tap and threaded it into the valve. Threads in perfectly. Everything looks good there. So then I thought, well, maybe my die is too loose. This is an adjustable die, so I tightened it up a little bit. This is the 1/16 NPT die again. Recut the thread again, and I did a couple of passes on that, making it smaller and smaller and smaller. Still, safety valve won't thread on. So I compared the thread form to the tap with a magnifying glass. Looks to be perfect. Safety valve won't thread on. So I had to finally throw in the towel, and I recut the thread in the safety valve with a 5/16 27 bottoming tap. I honestly could not figure out what the thread in this thing is. I don't know why my 1/16 NPT die will thread onto the part that mates with this, yet when I cut a part with that same die, doesn't thread on. No idea. But after recutting the safety valve as a straight 5/16 27 thread, now it threads on perfectly. To this day, I have no idea what that thread was, but it works now. I am on record as strongly disliking tapered pipe threads. They are a nightmare in every single way, and this experience has not endeared me to them further. Okay, big chunk of brass now. I'm going to make the base for the chimney. It's a decorative tapered piece, and I've got this big chunk here that's kind of oversized, but I'm going to try to preserve some of it here. So I'm dialing it in. I'm using the 4-jaw, not for concentricity, but mainly for grip, because 4 jaws are better than 1. So when you got a big heavy chunk of material, the 4-jaw is a little extra safety. So I'm going to face that off, as is tradition. Now my thought was, I'm going to use a hole saw to carve out the center of this thing, and that will allow me to preserve a bunch of the material, because I don't want to really turn all of that stuff to chips. So I've got this hole saw here in my tool bin, and it's a good size for this purpose. Unfortunately, the pilot drill was having trouble clearing chips, and it needs to disappear inside that hole, so that's going to be a problem. So I went ahead and just pilot drilled it all the way through with a regular drill, and this way the hole saw will be guided through without having to worry about clearing chips in there. So in we go. I slowed the lathe way down. I've never used a hole saw on the lathe, so I wasn't sure how good this was going to work, and the answer is it works extremely well. That's cutting beautifully. This hole saw was donated to the channel, so I had no idea what kind of condition it's in, but it's carbide tipped, and it seemed sharp, and is cutting really, really well. And this plan seemed excellent until I got to about here, and I realized the flaw in my plan. In order for this to work, you have to be able to push the hole saw all the way through the stock, because there's no way to part it off inside there. And this hole saw has a shoulder on it, so I can't push it all the way through. Well, it was a cool idea, but it's not going to give me the depth that I need to clear out that center and preserve it for future parts. So I had to bite the bullet and just drill it all the way out with a succession of larger and larger drills until I exceeded the strength of the taper on my tailstock and had to switch to the boring bar. Speaking of which, I have an exciting new toy in that department. This is the Shrum Solutions Carbide Boring Bar, and this is not a promotion. He sent it to me just to see what I thought. And let me tell you, I like it. This is a solid carbide 3/8 boring bar, and I've got 3 full inches of stick out on this thing, and I was doing 80 thou passes, not a hint of chatter. This thing is amazing. I have a mild steel boring bar that's much thicker than this and would never be able to do a job like this. So I gotta say, this thing is my new favorite boring bar, hands down. I'll link to this below. Again, not sponsored. He didn't ask me to mention it on the channel. I'm just doing it because I like to tell you guys about tools that I love. Now the finish in there is a little bit funky just because it's not really the right insert for brass, but it doesn't matter what the inside of this thing looks like. In fact, a little bit of roughness in there is actually going to help hold the chimney in place. I'm aiming for a very specific fit here. I want the copper pipe that forms the body of the chimney to be kind of a hand press fit, if you like. Something in the ballpark of a locational transition fit, like just a couple of tenths of clearance, something like that. Basically, just enough that you can push it in by hand, but it takes some effort, so it's not going to be held in by solder or Loctite or anything like that. It's just going to be pushed in place. And let's see how I did. This is the pipe for the chimney, and yeah, that's perfect. It took some effort to get it in there, and it's going to stay in place on its own. Now I'm going to do the tapered section, which is always an interesting operation. I'm doing it in reverse from how you would usually do a taper, as you'll see here, just because it's going to be easier to do the other features on this part. So I'm laying out where the shoulder is going to be, and I'm making that real quick. This shoulder seats down in that hole that we made for the smoke box. I'm going for a very specific fit here as well. I want a nice snug fit, and well, yeah, I kind of blew that a little bit actually. That fit is looser than I was hoping for. Well, that's okay. It's going to be heavy enough that the birds won't be able to steal it anyway. I'll put a generous chamfer in there based on some armchair engineer idea of more efficient flow of gases up the chimney. I don't know. Look, I put a big chamfer in there, okay? For the taper on the body, I'm setting my compound to 7 degrees with the protractor, and I'm using a light in there to get it dialed just right. It's not super critical, but by getting the angle as accurate as possible, I can make sure that my taper ends in the right place and the overall length is about what I wanted. Now, the end of this taper is really close to the chuck, and you got to be careful when cutting up to a tapered shoulder like this, because the shoulder itself is at an angle, so the deeper you are in that shoulder, the closer you're actually getting to the chuck, and that can get you, let me tell you. So here's a trick I learned from Frank Hoos. Put a piece of tape on the chuck or on the thing that might hit the chuck, whichever is easier, and that'll start making noise when you get too close. On the final pass, I don't want to reduce the overall diameter of the base any more than necessary, so the Sharpie marker there helps me get an accurate touch off and do that final finishing cut, feeding with the compound, of course. I put a catch rod in there because I wasn't sure if finishing the taper might actually weaken the material too much up there, but it didn't. So I can mark the final length and part this guy off. Once again, I got the catch rod in there because this thing is actually fairly heavy. There's a good amount of brass in there. And Yahtzee. Onto the chimney next. I'm using my odd leg dividers to mark the length that I want, and I'm marking it all the way around, and that's because I'm going to use the fret saw again. This pipe is too small and delicate for my big horizontal bandsaw. The vise would crush it, but I do want a nice straight cut, so I'm not using the portable bandsaw. Hence the line all the way around, because that makes it a lot easier to keep the fret saw straight. And let's see how we did on squareness. It's actually pretty good for a freehand cut, but I'll square it up a little better with a file. This doesn't have to be great. Both ends of it are going to be covered, but I want it to seat nicely in the mating parts, so that looks better. I'm going to go ahead and install that in the base now. Might as well. So I get it started, and then it takes a pretty firm push to get it in there, and that will stay there basically for life without any kind of adhesive or other retaining system. Now I have enough stock here left over if I pull it out a little bit to do the decorative trim ring at the top of the chimney. So I will do that. I'll start by facing off the scrap as is tradition. It's running out a little bit there because I moved it and didn't dial it in again, but that's fine. We're only making decorative parts here. I turned the OD down to the outer diameter of the part. I have a decorative double curve on this, so I'm going to cut half of that curve using the same corner rounding end mill trick. But now I need to cut the other side. So how do I do that? Well, I'll show you. It's a pretty neat trick. But first I have to finish boring out the center a little bit. The big bore that I did earlier didn't go all the way through. You can see I've left a shoulder there that's going to register the top of the chimney pipe. And then I measured the correct place to part it off and parted it off. So now I can flip it around and cut the radius on the other side to complete the half circle, but this ring is too small to hold internally on my chuck and too large for any mandrels that I have. So here's a trick that you see big machinists with big machines do, but it works for little machinists with little machines too. And that is, you get a smaller chuck and you hold it in the bigger chuck and you can use it to hold smaller parts. This is a little tiny, like 2.5 or 3 inch chuck, and I forget exactly why I own this. I had a fixture in mind that I was going to build and didn't, but this didn't cost very much. It's a, import thing. It's not very well made. I start by dialing it in on the forge jaw to balance the mass, and then I put the ring on there and I dial the ring in again to get it running true, and that cancels out any runout that's in the little 3-jaw chuck. And this was working really well right up until it wasn't, because I was too afraid of damaging my little step cut on the inside of this ring, so I didn't tighten it as much as I should have, and yeah, it came loose. Dinged it up a little bit, but that's okay. It's got beauty marks now, so I put it back in, tightened it more, and finished that curve. I faced off the worst of the ding marks, and yeah, it still came out nice. I also blended the curves a little bit with a file there just to finish it off nicely. Okay, let's install that on the chimney. This is the same kind of aggressive manual press fit as the base had, which is what I wanted, so that went on there very nicely. And those will never come apart. Really nailing those 2 dimensions makes me feel better about kind of blowing the dimension on the base of the chimney. These parts will remain visible, so I'm going to have a go at making them look nice. Metal polishing is not my forte. I'm very new at this, so bear with me. But I started by cleaning it up with acetone, and then I took Brasso just to clean the factory tarnish off the copper pipe. The brass parts are freshly machined, so they're already nice. And then I cleaned it with acetone one more time, and to keep everything from tarnishing, I'm going to apply clear brake caliper paint. This is actually a tip I got from a viewer that brake caliper paint is high temperature. Of course it is, and it comes in lots of colors, including this clear coat. For the Smokebox cover, I hit it on the Scotch-Brite wheel to get the worst of the crud off, and now I'm going to do some sanding on it. So I've got wet dry sandpaper here with a little WD-40, and I worked my way up from 320 to 600 and 800 and finally 2000. And then from there I went to the buffing wheel, so I've got black Jeweler's Rouge on there, and I'm going to give it a nice polish. Now again, this is all new to me, so don't take this as a how-to for how to polish brass parts. This is just me trying some things out to see what works. The first lesson is that, much like painting, the quality of the finish depends entirely on how good the surface is. So you can see that I've got some surface imperfections, like that ring that goes around the outside there that never really came out because I didn't do enough sanding. But the polish looks pretty good. You can read the scale in it, but there are a lot of fine scratches there as well. I think I kind of gave up too soon on the polishing wheel. I should have stuck with it longer, but for my first attempt at polishing anything, I'm pretty happy with that. I chased the threads on the boiler bushings with a tap just to clean any silver soldering crud out of there. And let's do a test fit. So you can see how the Smokebox lid will go on there, and then those threads will take a nut to hold the lid down. However, this is when I realized I had not designed a way to put a wrench on this fitting, which is a mistake I make a lot. So I made it again with a taller bushing to expose more of that thread, and you'll see why here in a moment. Now what I can do is thread that in, and there's more threads exposed, and this will give me space to put wrench flats on the upper area of the exposed threads, because I need to be able to put a wrench on it with and without the Smokebox lid in place. So I'll set it up in the mill in a collet block. I used a gauge pin in the center there to act as support for the outer edge there, because it's sticking out in space quite a bit. And then I machined some wrench flats onto the upper threaded area. So you'll still be able to thread the nut on over those wrench flats, but you'll be able to use those flats to both tighten the steam pipe into the bushing and also tighten steam fittings to the top of that steam pipe. To quote Jimmy DiResta, you go to school on the first one and, well, sometimes the second one too. Yeah, I blew one of the major dimensions on that one, so it was a zombie part that never left the lathe. test fit time, so the steam pipes will thread in like that. Smokebox cover goes, oh, yeah. It seems that something is not quite aligned, and I was a little too optimistic with the clearances that I left on those holes. Probably one of the bushings in the top tube sheet there is ever so slightly crooked, and because of the long length of the steam pipes, it's enough to misalign things enough. So I used my no-good deburring tool there to just open those holes up a little bit, just make them slightly oval until it fit. To hold it down, I'm making these decorative nuts, so I turned and threaded this piece of stock and I cut flats on the sides with the mill, and now I'm putting it back in the lathe and I'm going to part off 2 nuts. I didn't want to make just standard hex nuts here because, you know, imagine if this was a full-size boiler, you wouldn't put a giant nut on there. It would be a bolted flange, but I don't want to make a tiny bolted flange. I'm not that crazy, at least not yet. So I thought, well, I'll make these kind of decorative, rounded, flat-sided rings, and they'll act as nuts, but they'll look a little nicer than hex nuts do. They don't have to be very tight. If you tighten them too much, you're just going to bend the smokebox lid downwards. And you can see how those wrench flats allow me to also then tighten the steam fittings that go above the lid. So on one side I've got the safety valve, and then on the other side I've got a PM Research globe valve for the steam output. Now you can make safety valves and globe valves yourself, but you know, you got to draw the line somewhere on every project. So maybe next time I'll make all the valves myself. But for now, Chimney goes on, and I'm pretty pleased with the final result. That's it for the entire Smokebox assembly. I hope you enjoyed watching me make this thing. If you like this content, see if you can throw me a little love there on Patreon. That really means a lot to me, keeps this channel going. I'll see you next time.